Hello, welcome to Agile Tech, and this is the part three of chapter seven of the systems life cycle. So we'll be looking at development and testing. Now, you need to observe that development and testing is a two-way process, right? Because we're talking about the development, why it is being developed. Then we have development phase, we have the testing phase. Once it has been developed, then you need to test it, to test what has been developed, to test, and there are so many testing that will be run on it, which may uncover a need to either design the solution several times, because in the testing you're going to notice a lot of mistakes, bugs there and there, and then there's a need to make a redesign of it. Okay, now testing, the need for testing. Now, once the design stage is completed, it is then necessary to create the system and fully test it. I've never seen a car that's been developed and you don't test the car before purchase, right? Before making it to the public. You have to run a test. That's what we are simply saying. You have to run the test. Okay? You have to run the test. Okay, that's what we talk about running the test. Now, it is necessary to create the system and fully test it. Now, this section considers some of the development stages, right, and the testing strategies which are often adopted by the system analysts. They are always often adopted by system analysts. Now, if the system contains files, for example, a database, then the file structure would need to be finalized at this stage. Okay, now there are some things you need to understand when we talk about the file structure. Yeah, just because I'm actually going there right now, so we can talk about the file structure, the data structure. Now, I think we see that you can actually watch the videos, the part one, the part two. They are there essentially to guide you. Yeah, we talk about the file structure here, and we talk about the data structure as well. Okay, now talking about how these files are structured and the data are structured as well. Talking about in the database, how the fields, the records, what makes a file, what makes a record, what makes a field, and which field is the right one for a primary key, and what the essence of the primary key, and the likes of that. Okay. Now, so it will be finalized at this stage. For example, the type of data is being stored in each field, length of each field, right? That's the file structure, and which field will be the key, like we said, how will the data files be linked, etc., etc. Once the file structure has been determined, it is then created, okay, and needs to be fully tested to make sure it is robust when the system actually goes live. I mean, robust all about that it can be able to run on any system, an operating system as well. Now, because it is important that the correct data is stored in the file, it is so important that the correct data is stored in the file. There are certain techniques that needs to be adopted to make sure the data populating the files or the database is at least of the right type. Okay, and it conforms to certain rules. Okay, and then we're talking about the validation routine and the verification method are used to ensure that this happens. Okay, I explained, and I'm going to cite it again in the part two of this video. We said the routines need to be fully tested. They make sure the routine endeavors to make sure that those data follow those criteria that have been stated in the system. Okay, and they are tested to ensure that they do trap unwanted data, but also make sure that any data transferred from the paper-based system to the electronic system has been done accurately. Okay, another thing we need to observe is any system being developed, we have what we call some form of what we call user interface. Okay, this type of details has already been considered, and they are used to actually interface with the final system that needs to be identified. For example, how the screens or any of the input device will be used to collect what data, and the way the output will be what presented. Okay, for example, especially hardware is needed. For example, people with disabilities, then it will necessary to analyze how the device will be used when it is implemented, followed by thorough testing to ensure the user screens are what user friendly, and that the correct output is associated with the input of the system. You don't want to input something and what you're seeing is a different thing. No. Okay. The test design, it covers how the system is going to be tested. Now we are looking at a table here showing the test designs, how to be considered. We're talking about testing the data structure. Why are we testing data structure? To determine how we can test all data in their correct format. That's the data structure. We're testing them in their what? Correct format, or how they are going to be stored in a correct way. For example, how the weather data would hold data what? Correctly. Okay, whether that table is going to hold the word data word correctly or not. The file structure, right, should test all the files functions properly. What are we talking about? The data is stored in their correct format and can be what correctly what retrieved. Are we getting it? The input format. So we have looked at the data structure to check if the tables can be able to hold data correctly. The file structures, if the data are in their correct format. Now we look at the input format. Now these are test designs, and we have 5 of them. Okay. Now for the input format, the testing design should determine how we can test that all data can be entered into the system correctly. What do I mean? If a date is to be entered, does the input format permit this date to be entered correctly? Is it the correct format? These are the things we have to look at. Now for the output format, the test design should determine how we can test that the screen output, talking about the screen layout and the report layout, output layout, are all in their correct format. For example, are the output result clear? Are they complete? Are they correctly matched? Are they matching what? The input data. You're typing or the input that you're having, and you want to generate a report. Are the report being generated the same as the input in the database? Output format. Validation routines. It tests to see whether the data is needed, is to see if all the validation rules would work. For example, does the system correctly reject unreasonable data being imputed? I've given a range between 10 to 20. Somebody puts in 21, somebody puts in 9. It should be able to reject it and not accept it. If it accepts it, it means that validation routine needs to be what? Re-evaluated. Okay. Then we have the test strategies. The test strategies. Software is often developed in what we call modular forms. Okay, and this method allows it to be broken down into smaller parts, and those smaller parts are known as what? Modules. So that's what software are just developed bit by bit before they are what? They are being integrated as what? As a whole, right? And each module is developed separately by a programmer or a team of programmer. So the programmer can be in charge. One programmer can be a certain or a team of programmers can be in charge of database. The other one is in charge of the interface. The other one is in charge of maybe certain certain modules in the software. Everybody working bit by bit, and then they now bring the whole software as a whole. Okay, each module needs to be tested, and that's why you test each of them separately to see if it functions correctly. Any problem resulting from the testing requires the model to be modified and then tested again. So you test them separately, you bring them together, and then you test them as a whole. Okay. Once development of each module is completed, the whole system needs to be tested as a whole. Like I've said, which all the modules function what together. Even though each model may work individually satisfactorily, when they're all put together, right, there may be data clashes or incompatibility or memory issues. These are the reasons why testing, not just in module but as a whole, is very, very what important. All this will lead to a need to improve the input and output what method, talking about the file or the data structure, talk about the database structure. Okay, validations and verification methods, then fully test everything what again. So once all this will now lead to what, you improve the input, you improve the output method, you improve the file or database structure, you improve the validation and verification method, and then fully test everything again. It is a very time consuming process, but it has to be perfect as possible before the system uses what, live what, data. So for example, we have here the modify module if any errors are found. So for module 1 you test, for module 2 you test, for module 3 you test, module 4 you test. Now the modules are now combined to form the what, the final what, program. And what are you going to do? You still test. You modify program if any errors are what, found. Now that is the what we call the test strategies. That is it. You modify each of the module individually, you bring them together, and then you still test again. Then we have test plan, test data, and live data. Once the testing design and strategies have been defined, it then combines, it then becomes necessary to formulate a test plan for each module. The test plan should include what? What are the test plan? A list of all the tests to be performed. What are the tests you want to perform on them? What data is to be used in the testing? What type of testing the data is needed to check? Now it could be a normal, an abnormal, or what, extreme what, testing. What live data should be used? What the expected outcomes are from the testing? Do the actual outcome match what is what expected? Those are the things we look out for, right? The list above includes the type of data referred to as normal, abnormal, extreme, and we're going to look at it. Before looking at a sample text plan, we need to define these three types of what, data. These are the three types of data, right? For the example we use is inputting a date into a database field. So we're using date as an example. The data must be what? Must take the format DD, MM, YY, and all data must be what? Numeric. Now let's do this. For normal means this is the data which is acceptable or valid and as to be what? Expected. It has a known outcome. For example, the month can be what? A whole number which should be in the range of what? 1 to 12. Remember, we are using what? All must be what? Numeric. So we can have 2101, okay, 21 1 1994, okay, or we can have 24 24 2 1986, or we can have 24 6 1972 or thereabout. Okay, now we have extreme. This is the data at the limit of what? Acceptability, validity. So they are the limit of acceptability or what? Validity. Now for the normal, we have them in the range of, for months, we have them in the range of what? 1 to 12. So 2 is normal. They're usually in the middle. So we can have 5, we can have 6, we can have 7. It's normal. But for extreme, they are at the limit, at the boundary of acceptability or of validity. So the months can either be of 2 end values. It can either be 1 or 12. Are we together? It can either be 1 or 12. We have abnormal. This is the data outside the limit of acceptability or validity and should be rejected or cause an error word message. Now, we look at the normal, which is acceptable or valid, and of course has the known outcome. We look at extreme, which is at the limit of acceptability, okay, and that they have two end values. Abnormal, they are outside the limit of what acceptability or validity and should be rejected and can cause what and or cause an error message. What are we saying? So if it's within the outside boundary, I'm giving 1 to 12 and we're having -1, it should give me an error that this is outside the boundary of what acceptability. Okay, now for example, any value less than 1, 0, -1, -15 is abnormal. Any value greater than 12 is also abnormal. If there are letters added to it, or January, February is abnormal. Non-integer values like 3.5, 10.5 is abnormal. Okay. Once a system has been fully tested, it is then tested with live data. This is the data with known outcome. Live data is what entered into the system and the result compared with those produced from the existing what system. If the two outcomes do not match, then further modification to the system may be needed. Okay. For example, live data, January, that's abnormal. Expected result, an error message should what be output. Actual result, the data was what accepted by the system. Any action, validation routines or month element needs to be what rewritten, then the system retested. We have 0. The message a 0 value is not permitted should be what output. The new system crashed when 0 was what input. What is the action? System needs an error trap such as if input then output, no 0 should be allowed. Now, example of a test data. Okay, we designed a test model where the temperature input, which could range in temperature like 21 Celsius to 50 degrees Celsius, etc. Okay. Now let's look at any temperature outside this range should be rejected, right? Okay, they said these are example of a test plan. They said is to design a test module where the temperature are inputs which must be in the current range. We talk about range check, right? 21 degrees Celsius to 50 degrees Celsius. Any temperature outside this range should be rejected. Now the input temperature can be integer or real. Okay, the real are decimal numbers. Okay. Now data set A, data input 35. What type of data input is that? Normal. Okay, yeah. Data should be accepted. Actual outcome, none. Test B, data input 45, normal, should be accepted. Test C, data input is 25.5. Now, it's normal because they said the input temperature can be what? Integer or what? Real. So it becomes normal. It can be an integer, it can also be what? A decimal. D, 21. They say 21 extreme because it is what? It is what? Within the boundary of what? The limit of what? Acceptability of what? Validity. Okay, so of course it can also be accepted, but it's extreme. Data set E, 50 is extreme, right? Now data set F, 50 is abnormal because it is neither within the range or it's neither within what? The boundary or the limit of acceptability. 20 is also abnormal because it is not within the range. 51 is abnormal because it is not within the range but outside of what? It is outside the limit of acceptability and therefore it should be what? Rejected, or an error message what? Given. -5, 100 point, all these are what? Abnormal. Now data shooting should come from the test design and what? Strategy. If the system works correctly, the test results for this column should be the same as the column of what? 4. If there are any what? Discrepancies, the model will need to be modified and the testing what? Repeated. Okay, just a heads up on that. All right. So here is an exercise given and I'm going to be giving my students in class to actually do this. It will be a live example I'm giving, but I'm just going to answer a few one. Okay, all right. So they say use the example of a date in the format DDMMYY when answering the following three questions. Consider the following 20 pieces of data and decide whether each data item is normal, abnormal, or extreme. So this is an example I'm going to give my a kind of like a test I'm going to give my students to do, but for the sake of outside students all over the world, I'm just going to just answer a few of them. Okay, so data item 15. They said, what are we using? They said, consider the following 20 pieces of data and decide whether each of them is normal. They said, example of a date in the format dd/mm, and this one falls within the field. So each of them have the field. So data item 15 and the field for month is 1 to 12. So is it, we're going to what as we do a tick. We're doing a tick. So is it normal, abnormal, extreme? 15 is outside the limit of 1 to 12. So it's what? Abnormal. All right. So 12 is what? We have one. We have extreme, which is what? Within the boundary, and then it has only two end what values, two possible values. We have the first and the last, and 12 is what? The last. So it's going to be extreme. Then we have 07. So 07 we have for 07 for the month. Consider the following 20 pieces. For 07 we can say is normal, because 07 is actually 7, right? Because sometimes the month can also be written 0 7, so it's still what? Normal. 1.6, they were not told, unlike this, that the input can be integers or real, so that becomes what? Abnormal. 1 is normal, 0 abnormal, 13 abnormal, March abnormal, 1 extreme, 31 abnormal, 18. Geez, sorry. I got a hold of myself. I'm sorry, I got a hold of myself. Okay, let's look at it now. So we are done with month. Sorry, we're done with month. For day, we have what? How many days in the month? 31 days, right? So we have 1 and 31. I got a hold of myself. So for 1, we have extreme because it's within what? The limit of what? Acceptability or validity. And 31 is, so they're outside the boundary, and it has two values, two end possible values, 1 or 31. So 18 is within, so 18 is normal. Tuesday is abnormal. 45 is abnormal. 0 is abnormal. 30 is normal. 00001 abnormal. Oh, sorry. We are now back to year. Now for year, we have 1990, 2020, and thereafter. So it's difficult to know the year for the extreme for year. So how are we going to do it? Yes, we can do 001 to 2021 as the time of this textbook. So 001 to 2021. So 001 becomes extreme, 2021 becomes extreme, 90.55 abnormal, minus 25 abnormal, 1854 normal. So we are done with that. I'm going to give my students. So you are lucky that I'm doing this for you. All right. Okay. I'm not going to do this one. Okay. So we have other things to do. All right. So we'll end this video right here, and in the next video we're going to look at implementation. Please do well to subscribe to my YouTube channel for more videos. Okay.